guys, welcome to another lab video. This is a heat transfer lab video. We did one a couple days ago where you kind of got to see some things happening, but now we did some notes yesterday, and so you should have some vocabulary to go with it now. And so specifically what I want you looking for as you're doing this is where's the convection, where's the radiation, where's the conduction. I did them in the wrong order, which is why I got confused. It's always conduction, convection, radiation, CCR. It's not just the name of a band. It's heat transfer. So this is your lab sheet. And before you start, you've got a diagram of the setup. I basically have a strip of aluminum foil across this pan. You can use a couple of beakers or a pan. These pans work nicely. I've got a candle right in the center. And this is going to be my first, by part one, is a candle in the middle. I've got 5 chocolate chips across my aluminum foil bridge. So if we pan over here to our lab sheet, what we have is this diagram, and I've already written in here what order I think the chocolate chips are going to melt in. I think the middle one will melt first, and then this one, and this one, then that one, and that one. So we'll see if I'm right or not, because when I'm done, I'll write the actual numbers here. I'm going to write down how long I think it's going to take to melt all the chips. I'm thinking 3 minutes. The time the candle lit, I'm using a stopwatch, so of course when you first push it, it's 0. And then when all the chips are melted, then I'll note down the time, and that will tell me my actual total time. If you used a clock, you'd have to write down, like 2:12, and it finished at 2:16 or whatever. So depending on which way you do that. And then down here, underneath, I have a timeline. This is in minutes. You can see I'm going to have to add that to the lab sheet. But we're going to... I'm going to note here at what time each chip melts. So I'm going to have a timeline of what they melted, and that'll show me what order they melted in, which will help me see if my prediction was correct or not. So let's go ahead and get started. I'm going to light this candle.
I'm going to put it down so they can see at this level.
And we do know from past experience that chocolate chips get a little shiny and glossy when they're about to melt. So, start the timer. There we go. This is easier with several people because somebody can be manning the timer and somebody the flame and somebody can be poking the chocolate chips. Sadly, because of all our COVID constrictions, there will be no eating of chocolate chips this year. This is certainly something you could try at home with your parents and see if you have the supplies. It's kind of fun.
Don't do it without permission.
Yeah, never do science at home without permission of the adults who are in charge of you.
Yeah.
You see how this is already really soft. It's not completely melted. This one is also getting soft. That one not really. This one is pretty soft. That one. So the middle one is almost completely melted. I'd say that's pretty liquidy chocolate. That's at 56 seconds, so that was number C.
Less than a minute. Okay.
Less than a minute. I can still see kind of a hard knob on top of that one and that one.
Okay.
How are these? These ones are still just not quite there yet.
So it looks like that the heat next to it on both sides is is going to melt it.
Yeah, I think I guessed wrong.
Yeah.
So that one's done. This one, look at that one.
Yeah.
Both of those, they got done at the same time, so that would be B and D, and I'm at 1.5 minutes. B and D. Now I'm just waiting.
Doing that.
Yeah, I'm putting them there. These
like
are still
right between 1 and 2.
Yeah.
Okay.
Now this one's really, they're both pretty soft. This one seems to have a bigger chunk that's still hard. That one's almost there. I can feel a little kind of hard spot right there.
Still, that's amazingly fast.
Yeah, way faster than I thought.
So do you think something about the...
Okay, so that one's done. That was A, and I'm at just past 2 minutes. And this one's not quite there yet. Not quite.
I think you mentioned before we were on camera that the aluminum foil is...
Aluminum is a metal, which means it's a good conductor.
Yeah.
And it appears to be conducting our heat.
Yeah.
Okay, that one's completely melted now, so that was about just under 2.5 minutes. So, E. So,
she was close.
Stop my time. Stop. There we go. So, that was part 1, and I predicted 3 minutes, and it finished at 2:28.
This is upside down, but you can
So-
still see it.
The question, was my prediction accurate? No. Not only did they melt, okay, so this one melted first, like I said, but B and D kind of melted together, so they're both number 2.
Yeah.
And then A, and then E. So my predictions were off all over the place.
Yeah.
I did not predict any of that correctly, and that's okay, because in science, we try again. And I would probably, if I needed to know this for some burning scientific reason, other than seeing how heat moves, I would probably I'm gonna move that out of the way, and we're going to start with a new piece of foil for part 2. And this time, I'm going to move the candle to one end. I forget which way I'm put it on the paper. I put it at this end. Well, it'll look like it's at that end from where
Yeah.
you're sitting,
That's right.
from the camera's view. So
Yeah.
we'll do that. We're going to put the candle at the end. We're going to put our chocolate chips on, just like we did before.
Yeah, it's the very same setup except for the candle being at the end. So she's doing that right now while I show you this sheet.
All right, and then I've
All
got
of
to
that.
write down my predictions again. Based on what happened last time, I think they're going to melt in order. So I'm going to write that down. And I wonder if it'll take longer or shorter since it's coming from one end.
Ooh, that's interesting.
I'm going to keep it at 3 minutes because I have a feeling this might take a little bit longer.
Okay.
And again, we're using the stopwatch, so my starting time is 0. And I've got my timeline, which will be in minutes for where I write down as each one goes, and a clean toothpick. And I've got my candle, my fancy schmancy burner thing here, which I apparently can't use left-handed. There we go. Did it light?
Not yet. Can you not see it?
I can't really see it under there.
There.
There it goes.
Yeah.
All right.
Timer.
Oh, timer. There we go. All right. Well, that's fair because I was a second or two late on the timer the first time.
Yeah, that's true.
That makes my times fairly even. So I'm going to keep a pretty close eye on this because the last time it sure went faster than I thought. And these are not in a straight line, which is going to bug me. So now they're in a straight line and they're pretty equally. Oh, good heavens, look at that. That one's almost melted.
Oh. And this is a different piece of aluminum foil for it.
It's a clean
so
one.
It wasn't hot when we put it on there. So
No, it was cold.
yeah. Goodness.
Yeah, this one out here isn't doing anything. This one's starting to stick. This one is definitely starting to melt. That one's collapsing. This one is almost, I'd say that one's melted now.
Wow, yeah.
So we're at 46 seconds. That's about three
Which,
quarters.
by
So
the
that
way,
would be,
if you're doing this at home,
Okay.
it's semi-sweet chocolate.
yeah, we made the mistake of trying to do this with some milk chocolate chips this morning, and we could not get them to melt. And I have a theory about that, which
It's
may or may not prove. That was
108.
108, just a little past 8 was B. Let's check on this one. No, that one's still got a lump.
Mm-hmm.
So does that one. So does that one.
Taking a minute. Literally.
Literally. Yeah, so I think that semi-sweet chocolate has more fat in it. And fat melts really easily.
Yeah.
So, there's a little bit of a nub on that one.
Almost there.
Almost. How's this one doing? This one's not. These ones further out. This one doesn't seem like it's hot at all. Be interesting to see if we're able to get the heat to go all the way down the foil. That one's still not quite melted. There's a little nub there.
Oh, but it's almost there.
Almost. It's pretty puddly.
And we're at 2 minutes.
Yeah, so my 3 minutes might have been wrong again.
Well, just maybe just a little over.
Yeah, we'll see. Okay, so that middle one is pretty melted now. I'd say that was melted at 212. So about here would be C.
I'll show you her sheet right now. She's already got A, B, and C. Just over 2, just like B is just over 1 minute, 2 is just over, C is just over 2 minutes.
This one's starting to melt. You can see it getting all puddly on the bottom.
Oh, yeah. So it is traveling.
Yeah.
Sure it is.
It's just taken a while to get out here.
I wonder if that first one is going to burn by the time the other ones get melted.
It is entirely possible this one might get too hot. Although you cook these inside cookies at a pretty high, like a 375 degree Fahrenheit oven.
Yeah.
So it's kind of still. That's the funny thing. It's melted, but it's holding its shape. It doesn't go completely liquid. It's just too thick. That's an interesting property of liquids called viscosity. The more viscous they are, the thicker they are. Like syrup has a really high viscosity, and water has a really low one.
Yeah, like ketchup.
Took a class on heat transfer when I was in college the first time around, and that's what we looked at, was stuff like that. There's a whole science. You can take like a whole class just on heat transfer, and we're spending like 2 weeks on it.
Wow.
So that one's getting there. How's this one doing? Oh, he's just not even thinking about it.
Nope.
He's like, that fire is so far away, I couldn't care less. Wonder if he will melt. We're at almost 4 minutes. These guys at the end are really not getting the heat. I think this one's starting to get thick and goopy because the liquid in it is evaporating. And that one's still a little hard on top. It is melting, though.
Yeah.
You just have to be patient. Not that guy. That guy's not interested in melting at all. There may be a limit to how far the heat travels from a candle because you've got all the air. The heat can move into the air too and not just into the foil. That one's almost melted.
Do you want a new toothpick?
Yeah, maybe. That one's kind of icky.
Yeah.
There we go. We'll have to remember to put lots of toothpicks out for the kids at school. That's still got a little nub in the middle that's not quite melted. And this one's drying up because it's getting too much heat.
I think it's baking.
I think we're baking this. Yeah, it's looking burned on the bottom.
Yeah.
We're burning it because we left it on there so long.
And no, we're not going to eat them.
No, we're not eating these. That's disgusting. We don't know where this aluminum foil has been.
That's right.
All right, that one is melted now, and that was at 5 minutes.
Wow. That blew your numbers.
Yeah, I just apparently am not good at predicting melting times, and I have a feeling this one's not going to melt at all.
Wow, I really
Isn't that
thought it
interesting?
would.
It's too far away. This one's drying up and burning.
Yeah.
We did eventually get this one to melt, but I'm not sure we're ever going to get that one to melt.
Maybe we should let it go without the camera and just let them know. Did it ever burn? I mean, melt.
Did it ever melt? Yeah, I don't think we're going to subject you to that. We're going to let it go for a little while and see if it ever melts and let you know what the time on that is, but you don't need to sit and watch. It's like watching
No, we're at 13 minutes on
plants
the
grow.
video.
Okay, it's time to stop the video.
All right. Bye.